This video we're going to do Unit 3, Section 2, and these are characteristics of quadratic functions. So A is vertex form of quadratics. Well, let's write the vertex form first of quadratics. We got to have that. So vertex form is pretty simple. Hopefully you've already seen this. So vertex form is just y equals, before that, we have a parentheses x minus h squared plus k. That is vertex form. And then on top of that, just to add, while we're here, vertex of a quadratic is simply hk. The big thing is here on this one is you have to remember you always flip h. And when I say flip, I'm talking about the sign. So always flip sign of h. So if h is, negative, it'd be positive. If it's positive, it's negative. So that's vertex form, and the vertex comes from that. That's why they call it the vertex form. So let's look at number 1. I like to go through and label these. You don't have to, but it definitely helps. So we have A in the front, H is right here, and then K. So if we look at this, we have H is plus 3. So then if H is plus 3, our vertex, right, the H is going to be opposite, so you always flip it. So H will be negative 3. Next thing, K is 2 plus 2, so it's just 2. The K doesn't change, just the H, and that's the vertex. The second thing we need is the axis of symmetry. So the axis of symmetry, or I just do AOS, is just x equals negative 3. Because notice these two right here, so these two are the exact same number, and they always will be for axis of symmetry. So let me write that down here. I didn't write that earlier. So here we have axis of symmetry is simply x equals h. I guess I'll do it right here. So x equals h. So whatever h is right here is going to be the axis of symmetry. Okay? So since the vertex was negative 3, 2, axis of symmetry is x equals negative 3. And that's it. So number 2, let's do, okay, I'm going to go ahead and go through and label these again. I have A, H, and K. So if I look at H, it's minus 4. So the first thing I know is I flip that one, flip the sign. So vertex, I'm going to have, instead of minus 4, it's 4. And then for K, I have minus 1, so it's just going to be negative 1. Okay, and then I have axis of symmetry is x equals, and our x value is 4, so it's just 4. And that's it. Pretty easy. Alright, so let's move down and graph. Now we're going to do the same thing. And if I remember right, yeah. So these equations on 3 and 4 are the exact same ones above that we just did. So if you need to, you can look up there. But I'm going to go ahead and do vertex. We have negative 3, 2. Now the vertex is just like the lesson before this, the starting point. The vertex is the actual name. So from the middle, or from the origin, I'm going to go negative 3, so left 3, and then up 2, right? So there's my vertex. That's my starting point. And here's my A. My A is 1/2. So from the pattern that we did before, if we go over 1, up 1, over 2, up 4, because I have an A, I have to multiply these by A. So now instead of going over 1, up 1, I go over 1, up 1/2. So over 1, up 1/2. And of course, whatever happens on the right happens on the left. Let me delete those and just put the points. And then over 2, up 4 times half, or half of 4 is just 2, so I'm right here. And then I can draw my U through those points. Even though I didn't hit them, yeah, whatever. Main focus on this is the vertex, and then where the points are starting off to see if it compresses or stretches. Even though you can tell by A, it still needs to be graphed correctly. So that's it for number 3. Number 4, we have our reflection right here. And then we have H and K. So of course we know from above our vertex is 4, -1. So I'm going to go ahead and go right 4, down 1. There's my vertex. Notice I don't have an A to multiply, but because I have a negative in the front, I reflect. My U and my parabola is going to look like this. So I have the same pattern now from my vertex. I'm going to go over and down, right? 1, 1, and then over and down 2, 4. So my typical pattern, I don't change it because I don't have an A. So from here I can go over 1, down 1, do the same thing on the other side, and then over 2, down 4. And I can't do that on the other side. It would be about right here maybe if I had to guess, but pretty close. And then I would just connect my dots and I'm good to go. And that's it for the vertex form on that part. So now we can go to the next part. Alright, so next part is B, standard form of quadratics. So again, we're going to do the same thing, label vertex, axis of symmetry. But let's go ahead and write some notes first, just so we have them. So our standard, right? Yeah, standard form of quadratics. I'm sure y'all have seen this before. You should have. So standard form is just simply ax squared plus bx plus c. And that's it. Then axis of symmetry on these. So we have axis of symmetry. We're going to have x equals -b over 2a. So that's why it's important to know where a, b, and c are, because we need a and b to find the axis of symmetry. So let's look at number 5. Again, I'm going to go ahead and label. I have a, b, and c. Okay, first thing I have to do on these is I have to find axis of symmetry, because I can't tell what the vertex is so easily like the last ones. So I'm going to go ahead and do x equals -b over 2a. So now I plug in my numbers, right? So I have -6, but since it's -b, the b always flips. So now we have +6 over 2 times a. A is 2. So that is 6 over 4, which of course reduces to 3 over 2. So our axis of symmetry is x equals 3/2. Now, once we find the axis of symmetry on these, I have to take that number, so I'm going to take 3/2, and plug it in for x on both x's. So I'm going to have 2 times, now instead of x squared, I'm going to have 3/2 squared. Whoa, let me change that. And then -6 times my x again, so 3/2. And then -1. So now I just have to solve, and this will give me my y value for my vertex. Because I already know my x value is 3/2, same as the axis of symmetry. So now I'm going to go through this question. So I have 2 times, now 3/2 squared is 3/2 times 3/2. So on top we have 3 times 3 is 9. On bottom we have 2 times 2 is 4. Okay, now on the next one, I can, if you wanted to, reduce that. 6 and 2 becomes 3 and 1, right? And now I can do 3 times 3, and I don't have any more fractions. So 3 times 3 is 9. And then the minus 1 didn't change, so I just leave it alone. Now, notice on here I can reduce these also right here. So I have 2 and 1. 1 times 9 is 9. Divided by 2 doesn't change, so I have to leave it 9 over 2. But then I have negative 9 minus 1 is negative 10. Now, I want to combine these fractions together, right? So, to make this 10 is over 1, I want to multiply it by 2. That would give me 9 over 2 minus 2 times 10, 2 times 1. So 20 over 2, which then gives me negative 11 over 2. And that's my y. So if I wanted to go ahead and do the vertex and write it out like that, I'm going to have vertex is simply 3 halves, comma, negative 11 halves. And then my axis of symmetry is very similar. It's just x equals, and then my x value of my vertex, and that's it. So it seems like a lot, but once you get it down, once you practice, it's really not that bad. Plus, I'm pretty sure that's the only one with a fraction, if I remember right. But let's move on to 6. So 6, I have an A, a B, and a C. So again, I have to do the same thing starting out. So I have negative B over 2A. So again, B is plus 4, and so it would be minus, right? It's always opposite. So minus 4 over 2 times. Now notice, A on this one is negative, right? Negative x squared is the same thing as negative 1. Because, you know, no one ever writes the 1 in front of anything. They just assume that's what it is. So if I do this one, I would have negative 4 over 2 times negative 1 is negative 2. I simply divide that, and I have 2. Nice even number. Now I can take that 2 and plug it in for x here, and this x. So now I have negative, and this will be 2 squared plus 4 times 2, that's my x, right? And then plus 3. So now I'm just using PEMDAS to solve this one. So over here I have 2 squared is 4, so negative outside stays. And then 4 times 2 is 8. So then I have negative 4 plus 8, or 8 minus 4 is 4. And then of course 4 plus 3 is just 7. So I have 2 and 7. Now the way you'd write that, of course, is vertex is 2, 7. And that's it. Pretty easy. Alright, so let's move on to the next two. It should be very similar to those. So now we just got to graph the quadratic from what we have. So notice that 7 and 8, if I remember right, are the exact same as 5 and 6. So we've already done all the work as far as finding the vertex, finding the axis of symmetry. So if I go back up here, and I notice my vertex is right here, my axis of symmetry is right here, I can go and just copy that because it's not going to change. I already did the work. Now, if you haven't done the work, you're going to have to figure it out, but as you can tell, it's not too difficult. So I have 3 halves and negative 11 halves. That's fine. If you're good at math, you know that 2 goes into 3 one time with only 1 left over. So that's 1 1/2. That's the 3. So I'm going to go ahead and plot this in 3 halves. So if you need to, add little hash marks, right? Like these are the halves. And now you can just count every single half as a number. So if they do talk about something you don't want, then you can go through and add this and count it the way you want to, right? So you don't like halves, so you don't want to do halves. Well, you can go add them in there and just count it that way. So if I went 3 halves, now I start in the center still, right? I'm going to go ahead and change this to a different color. So I start in the center, and now I went 3 halves. So I'm going to go 1, 2, 3. And down 11. So negative 11 is down 11 halves, right? So I can go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So all the way down here, that's my starting point. Oop, I'm going to go ahead and erase all these other dots that I don't need. As soon as it lets me, there we go. So again, if it's not something you want to, you can go add the little hash marks and count it however you like. So there's my starting point, there's my vertex, and on this one, now this works the same as we did yesterday. So here's my A, B, and C, right? So my A. So on my pattern, if I go over and up, and then I go over and up again, so it's 1, 1, 2, 4. Now I multiply by A, so this will be times 2 times 2. So from here I can go over 1 and then up 1, 2. And it looks like it's right in the center of the box. That's because it's supposed to be. So I go over 1 and then up 1, 2. And then I go 2 and 4 times 2 is 8. So this will be kind of a lot to count. That's okay. So I go over 2 and then up 1, 2, 3, 4, 5, 6, 7, 8. So way up here. And over 2, up 1, 2, 3, 4, 5, 6, 7, 8. Now I can make my U shape. And voila, we got a graph. Alright, 8. 8, again, we'll go ahead and do A, B, C. Notice I don't have an A, but I do have this negative. And since I don't have parentheses, that negative is going to make my U, or parabola, face down from whatever my vertex is. So we look up here, we got the vertex already is 2, 7. So vertex is already known. So if I'm going to go over 2, up, oh wow, way up here, there's my vertex. And I'm going to use my pattern, right? So now I'm going down, so I'm just going to go over and down, over and down. So that's 1, 1, 2, 4. And my A is just a negative, so I don't have to multiply anything. I just follow my pattern. So that's nice. So from here, this is, let's see, this is 6 and 7, right? So this will make it easier. So I go over 1, down 1. Over 2, down 4. 1, 2, 3, 4. And do the same thing on the left. 1, 2, 3, 4. Now again, it doesn't have to be like super specific, but get what you can, get pretty close, do a rough sketch, that's okay. But that's my graph. Alright, now we're at the intercept form of quadratics. So before we do that, let's go ahead and go down here and write the intercept form. I just randomly change, that's okay. So intercept form is, if we have an A, it's out here. But we have x minus p, x minus q. Now, don't ask me why they got P and Q. I have no idea. That's just what they have. That's what it's always been. That's what I go with. Okay. Alright, so that's the intercept form. Now, the next thing you need to know is X intercepts. So my X intercepts are going to be P0 and Q0. Okay, now the only thing you got to remember on these is, I don't know if it'll let me do a little star. So always change signs of P and Q. So always change the signs to P and Q. I don't know why I did that. Okay, so it's just simply P0, Q0. Those are my two intercepts. And then the last thing you need is the vertex, right? So to get the vertex, the first thing you need to do is find the x. So vertex x value. That's going to be x equals P plus Q divided by 2. So same thing applies here. As you remember, change the sign of P and Q. So if you want, you can just draw like that goes to there and that goes to there. So whatever P and Q are, you're going to change the sign. Now, once you solve for x, the y value of the vertex, you just plug that number into the equation and solve for y. So I'm just going to plug it in. Plug into equation. That's all I do, and then I have x and y, and that's my vertex. Alright, so that's a lot of notes. Let's put this on a problem, and you'll see how this works out. So on here, first thing I'm going to do is, of course, label, right? So I have A, there's P, there's Q, and I want vertex and X intercepts. So the first thing I'm going to do is vertex. So for my vertex, I have to find X first. You always have to find X first because that's just how you have to do it. So X equals P plus Q over 2. Now remember, we have to change the signs of P and Q. So if P is plus 3, I'm going to do negative 3. And Q is minus 1, so I flip it and do plus 1 over 2. Okay, now I just add. Negative 3 plus 1 is negative 2. And then I divide that, that's negative 1. Sweet, I have X. Okay, now that I have X, I plug that into the equation and get Y. So to get Y, let me change colors. So Y, I'm going to do 2, and then instead of X, I plug in negative 1. And then, of course, instead of X, negative 1 again. And I'm going to solve for Y. So I have 3 minus 1 is 2. And then negative 1 minus 1 is also 2, but that's negative. And now I just multiply all these together. So 2 times 2 is 4. 4 times negative 2 is negative 8. And of course, I just realized I forgot there's a negative here. So negative, negative. So that's actually a positive 8. Good thing I caught that before we got too far. So vertex for this equation is going to be my x and y. So my x, negative 1, y is 8. Now here's the cool part. This is the part I like, is the x intercepts, right? I still gotta have those because it asked for it in the question. So x intercepts, I'm just gonna do that. I simply take P and Q, flip the signs, and add a 0 on the end, right? So my first one, so plus 3 becomes negative 3, comma 0. That's one x-intercept. The next one is, my Q is minus 1, so I just put 1, comma 0. That's it. Those are both my x-intercepts. That's why they call us x-intercept form, and or intercept form. And so yeah. So my x-intercepts are easy. It's finding the vertex that takes a little bit longer. Still not difficult, but you got to do it. So let's take a look at number 10. So number 10, I have A again, and then there's P, and there's Q. Okay, so first thing is X of my vertex. So my X is going to be, same as last time, P plus Q over 2. And I want to flip the sign, so if P is minus 2, I'm going to do 2. Q is plus 2, so I'm going to do minus 2 over 2. Of course, 2 minus 2 is 0. And that gives me 0. Pretty sweet. Okay, so now it's X, I got to find Y. To find Y, I simply plug X in the number, right, where X is. So I have 1/2. And then instead of X, I have 0 minus 2 and 0 plus 2. So same thing. Okay, so I'm going to go ahead and keep 1/2. That doesn't change. 0 minus 2 is just -2. 0 plus 2 is +2. Okay, so I can do 1/2. -2 times 2 is -4. Half of -4 is -2. So my vertex for this whole thing is, oh, that was a terrible parentheses. So I have 0, comma, -2. Because those are the two values that I found, here and here. Now I can do the easy part and get my X intercepts. First one is P, but I flip the sign, so it would be 2, 0. Second one is Q, but I also flip the sign, so -2, 0. And that's it. Now we just got to graph these. So here's the easiest way to graph these. I still want to label this because I still have A, I still have P, I still have Q, and this makes it reflect. So I'm going to go down like this. Okay? But here's the crazy part. I don't need the vertex on here necessarily, right? I mean, it would definitely help. And you know what? Yeah, I guess the vertex would be nice to have. I mean, it's not necessarily required for these, but I don't want to confuse anybody, so I guess we'll just keep using it, especially since we already found it. That's okay. So my vertex for this is, what would we get up here? This is the same one. -1, 8. So -1, comma 8. So I'm going to go ahead and do that. So from the center, I do -1 and then comma 8. Way up here. Now here's the cool part. I don't really need the pattern on this one. I just need my P and my Q. So my P is +3, and I switch the sign to make it negative. My P's and Q's are my X intercepts, right? So they have to stay on this, on this X axis on the line. So if this P is +3 and I flip it to -3, I just go -1, 2, 3, and there's my point. Same with the other one, X minus 1. I flip the sign, it's +1, so now it's over here. So I have my vertex way up at the top, and I have my two X intercepts. That is good enough for a sketch. That's all we're looking for here. Nothing specific. And that's it. So it kind of bypasses the whole pattern thing. You already have 3 points. Might as well plot those and just go on with your day, right? Alright, so 12. Same thing. I have an A, P, and a Q. Of course, we already found the vertex up here, 0, -2. So I'm going to go ahead and plot that. So I do 0, I don't go anywhere left and right, and then down 2. There's my vertex, my starting point. And I have P and Q, so I'm going to go ahead and just plot those. So P is -2, so I change it to a +2. Q is +2, so I change it to a -2. And I can just connect my dots from there. And there is my compressed quadratic. Pretty simple, I hope. If not, you'll let me go, or let me know. Alright, so last section is domain, range, minimum, maximum, increasing, and decreasing interval. So we're almost done. So I'm going to go ahead and go down here, and let's write some notes first. So for quadratics, the domain, wow, that keeps doing that, is simply just all real numbers. That's true for every quadratic function. It will always be true, so let's just leave it at that and move on to the next one. Range. So range really depends on A, or not A necessarily, is if there's a negative in the front or not. So if I have ax squared, right? So any kind of A where A is greater than 1, then I'm going to end up with y is greater than or equal to k, right? So if I'm greater than 1, I'm greater than k, which is my vertex, the y value part. And then of course if I have the same thing, so ax squared, but my a was less than 1, then I would end up with just the opposite, right? Y is less than or equal to k. Because my vertex is always my top and my bottom, or where it turns, so that's why it's my range. Alright, what's the next one? Next one is max or minimum value. So we have max or minimum value. So my max and min just equal k, whatever that value is. And remember, if you have to, just do x equals negative b over 2a. Then you plug that in, that'll give you k. So just plug in for k. Okay? So that's max or min. Of course, if a is positive, it's a minimum. If a is negative, it's a maximum. That kind of thing. Alright, so next one, increasing interval. So we have increasing. So I'm going to be increasing, let's say, if a is positive, right? So a is positive, my increasing is going to go from k to infinity. If my a equals negative, my increasing is going to go from negative infinity to k. Now, these are always parentheses, never brackets or anything else, because you never reach those points. Because on the first one, if a is positive, my u is going up, right? So that's saying from here on this way is increasing, right? And then, of course, if I have negative a, my graph's going this way. So that's saying that I'm going from negative infinity all the way up to my vertex. That's where I stop. Okay? So that's increasing. Decreasing is just the opposite. So decreasing interval, if I have a equals positive, then I would be going from, for decreasing, I'd be going from negative infinity to k. And if a is negative, just the opposite, right? I'll be going k to positive infinity. Of course, on this one, since I'm decreasing, it'd be the same thing, right? Got my normal u, but I'm coming to that point. And then the other one is negative. So I'm decreasing from my vertex and I follow it down, right? So that's, oh, then y-intercept is the last one. Wow, I wrote kind of big, that's okay. So y-intercept is always going to be 0, c, or the number at the very end. So y-intercept's pretty easy. Alright, so let's try and do all these real quick, since this is my last one. So domain is all real numbers. I know that's true. My range always starts with y. Next thing I would look at is a. Notice, there's no negative. So because there's positive, I am greater than or equal to, and now I have to find k. So here's the part that I got to do some work. To find that, of course, I'm going to do x equals negative b over 2a. So I have, let me just erase that to get it out of the way here. I'll write it up here like that. Alright, so negative b over 2a. If I go up here, I have a, b, and c. So negative b is negative 10 over 2 times 5. Okay, so negative 10 over 10 gives me negative 1. Sweet. That's my x value. Remember, that's x, not y. That's not k. I got to plug that thing in to my equation. So I'm going to do 5 times 1 squared plus 10 times 1 plus 2. So 1 squared is 1 times 5. So I have 5 plus 10 plus 2. Well, that's 15, 16, 17. So that's my answer, 17. So let's do the domain. Domain, of course, so go ahead and all real numbers, that's it. It's pretty easy. The range. Range always starts with y, and if I look at my a in the front, my a is positive. So with positive a, I'd be greater than or equal to, and now I have to find k, right? It's the y part of the vertex. So to do that, underneath here, I'm going to do x. I got to find x first. So x is negative b over 2a. So if I go back up here, I have a, b, c. So negative b is negative 10. So negative 10 over 2 times a, which is 5. So negative 10 over 10 gives me negative 1. Now remember, that's x, not y, or not k, right? So I got to plug that in and still find my k value. So I'm going to have, I'm going to go and write my equation. So I have 5, and instead of x squared, I do negative 1 squared, right? Plus 10 times negative 1 plus 2. So then that gives me 5 times 1 minus 10 plus 2. So 5 minus 10 plus 2. 5 minus 10 is negative 5. Negative 5 plus 2 is negative 3. So my range is y is greater than or equal to negative 3. Sweet. Now, this is the cool thing right here, is once I find the range, I have my max min value. It's the exact same number. So this can just be negative 3. The only thing is I have to know if it's max or min. If a is positive, it's a minimum value, not a maximum. Okay? Because my U-shaped, if I have that, looks like this. So that means that would make it a minimum because it's the lowest point. So those two answers are exactly the same. So that kind of helps. And it also helps that my increasing and decreasing interval use my x value on my vertex. So I do need that number. I don't find it for no reason, so I do need it. So I'm going to keep it going. And so increasing, well again, if I look at my u over here, I'm increasing from the vertex to the right, which means I start at my vertex, which is negative 1. And if I go forever to the right, that would be positive, positive infinity. Okay? And then decreasing, I'm decreasing just the opposite. So that means I start at negative infinity and I decrease until I get to the vertex, and that's when I turn, right? So I should have a negative and positive infinity somewhere, and my vertex, my x value, is on the other number. So these two should be the same, and then I have a positive and a negative. Okay? So if a is positive, my increasing is positive infinity. So positive a equals positive infinity. Okay? And that's on the increasing part. Decreasing is just the opposite. Whatever's opposite of increasing is decreasing. And then of course my y-intercept, y-intercept is always going to be 0, comma, and then whatever my last number, my c. So since I labeled these, I go up here, c is 2. So my y-intercept is 0, comma, 2. And I know that seemed like a lot, but again, with practice, these get a little faster, a little easier. So my last question, finally, right? Okay, let's go through these. So domain, automatically all real numbers. So that's done. Range always starts with y. And if I go ahead and go through, I have a, right? A, B, C. And my a is now negative. Negative would make my range less than. And now I got to find k. So I'm going to do the same thing I did a minute ago, where I would have x equals negative b over 2a. So my b is negative 3, so I flip the sign. So it's 3 over 2 times a. A is negative 1/2, which gives me 3 over half of 2 is 1, and it's negative, right? So it's just like that, negative 3. Now, if you want to, you can go ahead and put that on the increasing decreasing interval. So because we know a is negative, I know my parabola is going down. So if my a, so real quick, let's just go back. So on increasing, positive a is positive infinity. Well, the same thing is true with negative, right? So on the increasing interval, if I have a negative a, then I have a negative infinity on the increasing interval. Of course, you can see on this picture, here's my vertex. I'm increasing from negative infinity all the way up until my vertex, and then I turn around, right? So increasing interval, negative a is negative infinity. So I do negative infinity until I get to this number, negative 3. And then the decreasing, of course, is just the exact opposite. Negative 3 to positive infinity. So I got that part out the way. Now I got to keep going right here, because once I get range, I have min-max value, right? And then I can get the easy y-intercept to finish it off. So now I have to just take this negative 3 and plug it into my equation. So I have negative 1/2 times negative 3 squared minus 3 times negative 3 minus 2. Okay, so I have negative 1/2 times 9 plus 9 minus 2. That would be negative 9/2. I'm going to go ahead and change these. So 9 over 1 becomes 18 over 2. 2 over 1 becomes 4 over 2. So I have negative 9 plus 18 is 9/2 minus 4/2 is simply 5/2. Whoa, that's not a half, that's not a 2. So I have y is less than or equal to 5/2. And then of course this one is also the same number, right? And because this a is negative, notice that I'm at the top of my parabola, or my u. So the top would make it a maximum value, not a minimum. And then the y-intercept, the very last thing, is always 0, comma, and then c. Of course, on this one, c is negative 2. So it's just 0, negative 2. And that's it. Finally. Whew, that took a while. But it's okay, we made it. So hopefully you practice. There's definitely a lot in this one lesson, a lot to practice. So go practice a lot, get used to this stuff. This stuff will be on the test.